d theta d theta. Now, this is the arc. Now, let's see an arc. Let's put in theta direction. Okay? Now, this is quite easy, d theta. Now, this radius here is not capital R. Attention now. This is a capital R. This is 5. This radius over here is I called in part 3, lecture 4, I call rho. This radius is just R sine phi. See, that's the radius. That's why I separated. This is, attention now. Look, this is arc in theta direction. This is arc in phi direction. Now the vector dr is perpendicular to the phi direction and theta direction. You just look at this figure here. You see, this is perpendicular to this direction and this direction. It's quite easy to see the length of this arc over here. Okay? So, this arc over here is R theta. Sorry. Is R sine phi d theta. See? Now, you see dr, the modulus dr, okay, will be arc sine phi d theta, which is this arc, times r d phi. If you multiply, you already get r squared sine phi d theta. It's exactly the development of this determinant. Now, the element for fixed theta, just easy here. See? Then let's talk about the fixed theta. Fixed. I'll draw here. You see, what I'm calling attention is this. You don't need to express by the cross product. You just look at the figure. So in the air element, you have r d phi. You see, that's the arc element times dr. Why? Because in the theta direction, the vector is perpendicular to the r direction and phi direction. Okay? So that's you have the arc here times this length over here, which is r dr d phi. That's the result is the same as you, in this case, expand the determinant. You don't need to do that. In the last one, I have two arcs. I have the arc, in this case, in the theta direction, and arc, this case the length in the r direction. This one you can see clearly. See? You have here, you have, in this case, you have here this direction and the perpendicular here. So I have, in this case, A, and this one, AR, dr. So in the phi direction, you take the cross product. Okay, you just look the area. You have r sine phi d theta dr. So it's r sine phi d theta dr. Again, I'm repeating. You don't need to develop the determinant, expand the determinant about the using the cross product. It's quite easy. So you have the area element.